We've learned how to write and balance chemical equations. There's actually several different styles of chemical equations. What we've been looking at so far is what's often called a molecular equation. And so that's going to show the complete neutral formulas for all the compounds as if they existed as molecules. So here we have two ionic compounds, potassium hydroxide and magnesium nitrate. And as we discussed earlier in this chapter, when an ionic compound dissolves in water, when it's in aqueous solution, those ions separate from each other and they're not next to each other anymore. So this doesn't really represent what's going on in the solution. So what we call a complete ionic equation is going to show all of the things, the species, as they actually are present in the solution. So potassium and hydroxide would be shown as separate ions instead of together. And then one step further than that is what's called the net ionic equation, which is only going to show the species that are undergoing a chemical change. Anything that is not is just going to not be shown at all. So to write a complete ionic equation, we're going to write any aqueous strong electrolytes as separate ions. So strong electrolytes are going to be soluble salts, and by salts we mean ionic compounds. So these would be ionic compounds that are aqueous, strong acids, and strong bases. Hang on just a minute. So those would be ionic compounds, strong acids. So the book hasn't told you what the strong acids are yet. It told you what a strong acid is, but not which acids are strong. And so here are the strong acids. There's 6 of them. So we've got HCl, HBr, HI, very cheerful acid, hi, HNO3, H2, SO4, and HClO4. So these are strong acids. If we see those in an equation and we're writing a complete ionic equation, we're going to separate those into ions. Strong bases, the only strong bases we're going to run into are also soluble ionic compounds, so we don't need to worry about that. Anything that's insoluble, like a solid, or a non-electrolyte, like a liquid or a gas, or a weak electrolyte, like a weak acid, is going to be written as molecules. So, as an example here, we're looking at lead nitrate reacting with potassium chloride to form lead chloride and potassium nitrate. So we're looking at everything that has AQ as a state symbol. Those might be separated into ions. So here's the first one. This is an ionic compound. We're going to separate that. So this has 1 Pb2 plus ion and 2 nitrate ions. And so we write them separately. Because when it dissolves in water, that's what happens. Those ions separate and they go swimming off in all directions. The next one is KCl, also an ionic compound. We have 2 moles of KCl, so we're going to have 2 moles of potassium ions and 2 moles of chloride ions. Here we have PbCl2. This is a solid, meaning it's not soluble. So it is not separated into ions. So we're just going to copy that down. We're not going to change it at all. The only things that get changed have AQ. And this last one, potassium nitrate, again, aqueous ionic compound. We'll separate that into ions, 2K plus and 2 NO3 minus. Any questions? Yeah.
So you give us the balance equations and just flip it.
Yeah, so a possible exam question would be, okay, here's a balanced chemical equation. Write the net ionic equation for this, or write the complete ionic equation for this. Yeah.
And we would have to include the charges.
Yes. Because when you write the ions have charges. Yeah. So the only things that get changed have AQ after them. If it has AQ after it, most of the time it will be written as ions. The only exception is a weak acid. These are the 6 strong acids. All the other acids are weak. We recognize an acid because it starts with H. Okay, I won't be trying to trick you with that, but it will come up on homework and stuff. So there's our complete ionic equation. Remember we talked about 2 couples going to a party in a beaker, right? And so lead and nitrate came to the party and they're mixing and mingling, right? And potassium and chloride came and they're mixing and mingling and, getting around. But then lead 2 and chloride got into a serious relationship, like on the spot, right? And they're on the back porch and we haven't seen them all night because they're just into themselves, right? So this is a solid. These guys got into a relationship. They underwent a chemical change. What happened to nitrate ion? Nitrate ion was unattached when she came, and at the end of the night, nitrate ion is still unattached. So did anything really change for her? No. So we call that a spectator ion. She was watching lead and chloride get into a relationship, but it didn't happen to her. What about potassium? Potassium came, with a friend, but unattached, and is also going to go home unattached. So you see, nothing happened to those guys?
Did you also say, it's a polyatomic ion, which is why we just split it?
Well, this is a polyatomic ion, which is why we did not take it apart into smaller
Right.
things. Yeah.
Okay, so polyatomic ions we were split apart.
Right. Yeah. So to write the net ionic equation, we're only going to write the things that actually underwent a change, a chemical change. And so these guys didn't, and so we're going to copy down the things that underwent a change. So we've got the lead 2, and we've got 2 chlorides, and then we've got the PbCl2. So do you know the difference between your gross paycheck and your net paycheck? One of them's a lot smaller, isn't it? Because they took out a bunch of stuff. The net paycheck is what you actually get to do something with. The gross is what they said they paid you, but it doesn't really matter that much, right? So this complete ionic equation is like your gross paycheck. It's got some extra stuff in there that you don't get to do anything with. And so the net ionic equation is just the stuff that matters. So this concept is not a super big deal in Chem 1A, but it is a concept that you will need in Chem 1B because we need to be able to understand what a net ionic equation is. We need to be able to look at it and understand that, oh yeah, there's some other ions in that solution, but they weren't involved, and so we didn't show them in the reaction because it didn't actually matter who they were. So let's do an example here. Consider the following reaction occurring in aqueous solution. Write the complete ionic and net ionic equations for this reaction. So we're going to look at our first thing here. This is aqueous. Is it ionic or is it an acid? It's an acid. So if it's a strong acid, we split it up. Is it a strong acid? Yeah, it is. HI is one of the strong acids. And the way you know that is you remember it. So I'm going to separate that into its ions. There's 2 of the HIs, and so I'm going to have 2 H ions and 2 I minus ions. And then I've got BaOH2. Again, this one's aqueous. It's an ionic compound, so I'm going to split it up. This has barium ion and 2 hydroxide ions. And this is where being familiar with these polyatomic ions is really helpful because you're not going to say, well, that's I don't want to write this down as OH2, 2 minus, because that's not what that means. It means that there are 2 hydroxide ions. And then we have water. This has the phase or state symbol L. Do I split that into ions? No. I'm just going to copy it down. And then what about that last one? Should I separate that into ions? The BaI2? Yeah. Because it's an ionic compound, right? And it's aqueous. I'm just going to move that over there because I didn't leave enough room. So, barium ion and 2 iodide ions. Both of these are aqueous. These complete ionic equations take up a lot of space. So that's the complete ionic equation. So that's this guy. And then for the net ionic equation, we're going to get rid of the reactants and products that are the same on both sides. So what's one of those? 2 iodide. Got 2 iodide here and 2 iodide there. And barium 2 plus and barium 2 plus. So the invitation for this party specified that you had to bring a date, right? And so hydrogen ion had to bring someone to this party. Did it have to be iodide? Did it matter in the end if he brought iodide? No, he could have brought, I don't know, sulfide or somebody else. It wouldn't end up mattering because it was hydrogen and the hydroxide that ended up getting together. But he couldn't come by himself because you can't just have a beaker of hydrogen ions because that's going to just have a positive charge, and nature doesn't like when the charges get separated. They tend to come back together rather explosively like lightning. Okay, so he had to bring a friend, but the friend didn't get involved in anything that happened that evening. Hydroxide had to bring a date, brought barium along, but if sodium had come instead, it really wouldn't matter. So those guys didn't get involved, and so we're going to leave them out. We're going to end up with 2 hydrogen ions plus 2 hydroxide ions. It's going to make 2 water molecules. That would be the net ionic equation. This happens sometimes. Notice that all these coefficients are 2. A balanced chemical equation should have the lowest whole number ratio of coefficients, and so we should write this as H plus hydroxide to make water. Any questions?
If we were to leave it with the 2, would you mark it wrong?
I wouldn't mark it wrong. Master in chemistry might. Yeah. One of the beautiful things about chemistry is, like with math, many times there's one correct answer, one best answer. Right? So this is the correct answer. This is like an almost correct answer, but not quite. But in my book, most of the time that's okay. Good enough.